Hello, hello. This is a very muted and tired Ms. Nussbaum. I've got my notes all prepared and ready for this, but I'll tell you what, the brain fog element of COVID is very real, and I'm having a hard time focusing. So you have to be patient watching this video. Okay. So today we're going to talk about the Pythagorean identities. There are three of them. This is going to be one of the first things that goes on the back of your unit circle. So what we're going to do right now is we're going to kind of prove them. I'm going to go a little fast with these notes, or at least I hope I am. And if you need me to slow down, just pause the video and catch up, and then we'll be right together. Okay, so I want you to imagine that this is a triangle from the unit circle. Like, here's the angle right here. Here's the x length. Here's the y length. The point would be up here. And it's a unit circle, so the radius is 1. So if I did the Pythagorean theorem right now, this is a triangle from the unit circle. So if I did the Pythagorean theorem, I'd use x squared, this side, plus y squared, that side, equals 1 squared, right here, which is just 1. X squared plus y squared equals 1. This is the real basic Pythagorean identity, but we are going to change it in just a second. But for right now, I want you to write this out on your unit circle. In that little bottom corner here, there's going to be room for 4 things, and on the top one, I want you to write x squared plus y squared equals 1. So it looks like this. Okay. Now, we also know from our unit circle that cosine is x and sine is y. So I'm going to actually change this to cosine plus sine squared theta equals 1. Now, I know that it looks weird to have this theta here. Theta is just the angle you're referring to. So when you're talking about cosine, you'd say like cosine of theta. And when you square it, the square goes, excuse me, the square goes right by the word cosine instead of by the angle, because it's implying that the whole cosine is squared, not just the angle is squared. So this is the Pythagorean theorem, or Pythagorean identity number 1. This is the one that keeps coming up over and over again. Okay, now I'm going to have you go away from this for a second, and we're going to turn over the back side of our unit circle. So here's our big unit circle from the front. The back side should be empty. I'm not going to write on my back side because my ink is kind of bleeding through. So instead, I'm going to write on a separate piece of paper, just so that I have a nice copy at the end. So you're going to want to split up the back side of your unit circle. It's eventually going to look like this. So it looks like we need kind of 2 boxes that are a little bit more narrow, 4 medium-sized boxes, and then 1 big box at the bottom. So we're just going to eyeball it. Give maybe that much room at the bottom. Okay, so that's what mine looks like. And one down the middle. And then in this top corner, we're going to write the Pythagorean identities, and there's going to be 3 of them. And the first one we just talked about was cosine squared theta plus sine squared theta equals 1. Oop, I keep misspelling the word identities today. Identities. All right, so that's our first one. Cosine squared plus sine squared equals 1. So, going back to my note sheet, let's try Pythagorean identity number 2. This one, I'm going to use a different tactic, and I'm just going to prove it to you. The Pythagorean theorem identity is tangent squared theta plus 1 equals secant squared theta. So this is my second one right here. I'm just going to circle it right now. And now I'm going to prove it. We're going to be doing a lot of these proofs in chapter 7, the dreaded chapter. And what you're going to learn about proving trig functions, or really any kind of proof, is that the goal is to prove that these are equal by making the sides equal to each other. So you want something in the end that will look exactly the same on both sides, and right now these don't look exactly the same. So we have to kind of change one of them to make it look like the other, and you can't cross this line. So this line is important. All you can do is kind of change the way things look on either side. So I'm going to start by writing out tangent and secant in the ways that our unit circle says. So like it says here that tangent is y over x, and that secant is 1 over x. So I'm going to write y over x squared plus 1 equals 1 over x squared, which equals y squared over x squared plus 1 equals 1 over x squared, because 1 squared is 1. Now I'm realizing that I need a common denominator here, so I'm going to make this y squared over x squared plus x squared over x squared, so both of the denominators are x squared. And then I'm going to combine the two. Y squared plus x squared over x squared equals 1 over x squared. Okay, so now we're kind of stuck, but then if we look back here at this note we wrote down right here, x squared plus y squared equals 1, and actually while we're at it, let's add in cosine squared theta plus sine squared theta equals 1. And leave some space down there. We're going to add something there next chapter. But since y squared plus x squared is 1, I'm just going to change this top to 1. So I'm kind of using an identity we already have. And now you can see that the left side matches the right side. When mathematicians prove something, they usually write QED. I have to look up what that means. It's Latin. What does QED mean? It means quod erat demonstratum, which basically means that which was to be proven. So we proved it. You can say QED, put a little check mark, very satisfying. And that is the second Pythagorean identity that we'll be using. So on the back of your unit circle, you're going to write in the second one, which is, let's see, tangent squared theta plus 1 equals secant squared theta. These are the 3 formulas we're going to be using in the homework. Just 3 formulas. Not too bad. You're never going to have to be able to do these proofs